Welcome back to another episode of Freeform AI. My name is Michael Burke, and I do data engineering and machine learning at Databricks. I'm joined by my co-host. His name is
Ben Wilson. I build Huey processing queues to prevent local denial of service attacks on applications at Databricks.
Thank you for your service once again. Today we're speaking with Hamel. He has over 20 years of ML experience. He started his career at Washington Mutual and Accenture in the consulting space, and then took data scientist roles at DataRobot, Airbnb, GitHub Outer Bounds, Fast AI, and others. But currently he's working at Bain and Parlance Labs. And so Hamel, we've been chatting before the recording per usual, and you mentioned you're an eval meme. Why did you choose to be a meme in that space versus a different space?
Yeah. Just to clarify, I don't work at Bain Capital. I'm just a scout, like a venture scout. So people that are raising money, I can write them a small check. But it's on my LinkedIn regardless. Okay, back to your question, the more interesting question, the eval meme. Why did I decide to become an eval meme? So what does that mean? So when I looked around in the AI space, I noticed that a lot of people building AI products, most people, I would say, building AI products, don't have good intuition on how to test and measure those products because they're stochastic systems. Don't, you know, they don't have like some deterministic output a lot of time. Think about a chatbot. You ask a question, you get an answer. How do you measure like what you're building? Like how do you test that systematically? So a lot of people obviously use vibe checks. They eyeball the output and say, hey, it looks good to me, it looks reasonable, and move on. The thing that data scientists know how to do really well is measure stochastic systems and figure out ways like how you can tease like what is a stochastic system working, and how to run experiments systematically and sort of understand whether or not you're improving something, even if the output is, you know, like a blob of text. Like, how do you do that? And so I thought that was missing from the discourse. People were getting stuck on this very topic. And I thought, okay, like, let's bring back data science for AI, you know? And so, really, what that means is, in my sort of lens, that became evals, but really it's data analysis and data science for AI. I kind of lumped that into the word evals. I needed a name for it, so I called it evals. But really, that's what it is. It's like, okay, how do you look at data? How do you do analysis of your trace logs or your AI? And then how do you create metrics that make sense? And then how do you
Mhm.
avoid all these traps out there when you're building a product?
Yeah, so getting listeners potentially up to speed, evals is an absolutely essential part of the AI development. Essentially, it's evolved really, really fast over the past several years, but a lot of traditional metrics like NLP-based metrics where you have a supervised set and compare generated answers with expected answers, that gives you a way to know whether your quality of responses are high or low or medium. But one of the most challenging things that we run into is when we don't have a robust comparison metric, or when we don't even have a supervised set. So I'm curious, what are some of the issues that you see most frequently popping up in this space?
Yeah. The number one issue that pops up in the space of evals is, okay, you're building some kind of AI product and you're like, hey, I need to know whether it's good. You Google around, you say, if you go onto Google and you say, hey, how do I know if my AI product is good? You're going to be hit with a bunch of eval vendors. And you're going to be hit with eval frameworks. And those eval frameworks will come with a lot of generic metrics: hallucination score, conciseness score, toxicity score. And they're like, don't worry, plug in our framework and you'll get a dashboard full of metrics. That doesn't work. It's very confusing. And you get a dashboard like, helpfulness score 4.2, conciseness score 3.5, whatever. No one knows what the hell that means. And most of the time, it doesn't have anything, it has like very little correlation with what actually matters in your product, and it doesn't really correlate with the actual failures that are happening in your product. So what you want to do is you want to avoid that. You want to avoid that mostly. They have their uses in kind of like a very specialized sense, but not in the sense that they're advertised for. And we can come back to that. What you want to do is you actually want to look at your data. So when I say look at your data, this is like, kind of the sort of bat signal for any data scientist to be like, nod your head, yes, okay, what do you mean? And so what that means is, so in machine learning, like let's say you're building a classifier, right? How do you debug that? Well, the first thing you want to do is you want to start looking at the predictions, and you want to do. There's a technique called error analysis, where you look at the predictions, you see like what is going wrong, and you start writing notes. Like, okay, I try to classify a cat, but it's being predicted as a dog. Oh, it's like rainy. The picture is blurry. Like you start taking notes, right? And then you could do simple things. You can categorize those notes. You can do some analysis, be like, okay, like where are things going wrong in this model? And then you can, as a machine learning engineer, you would say, okay, let me go get more data for like these like issues that I see. And you would iterate. But looking at the data is super important. We all know that. Like if you're building any kind of system, any kind of predictive system, you need to look at what's actually going on to build intuition on what the failures are. So like it starts there. It's like, okay, you need to look at the actual logs of your AI system. You need to see where it's failing. And then you need to design specific metrics, product specific metrics that are specific to the errors that you're seeing. And then those should be your evals, not conciseness score. Conciseness might not even be an issue, or helpfulness score. Like, that, what does that even mean? But, if you have, let's say, if your product is doing something very specific, let's say it's helping you create appointments, and appointments are not being created correctly, then, now you can write a specific eval or specific test for that. And so the idea of, tests should, so what I found is that people get really drowned and overwhelmed in the like what I should eval. You can brainstorm infinite set of things that you can test when it comes to an AI product. The surface area is infinite. You can ask anything potentially, and you can, think of different ways things go wrong, but it's really helpful to ground it in what is going wrong or what you can simulate to actually go wrong, and kind of prioritize that, because evals are not free. Writing tests for AI apps are not free. They actually take effort. And there's different kinds of tests. So there's like cheaper ones, like this code based assertions, like unit tests essentially that you can do. And then there's LLM as a judge. LLM as a judge is a lot more expensive. It's basically a classifier that you are building. And if you got to build a classifier, you got to verify the classifier, just like any other classifier pre-LLM. So you got to do a little bit of work. You got to gather some labels to see like, is that classifier good? And so you can't build infinite classifiers like that. That would just be a bad use of your time. So you got to prioritize like what tests really make sense. And essentially that's what evals are about. And then, what I focus on is like, okay, like walking people through like, okay, how do you do that? How do you make this whole thing tractable? And which kind of like, what do you focus on, and all the nuances of like, okay, how do you effectively do this analysis or look at data, and how do you effectively, write these evals, and how do you deploy them and stuff like that. Essentially what it comes out in, really what I would argue, it's not a separate thing even. It's just a very core part of AI engineering. It's not like, oh, like I need to go do evals now, or how much of my time should I spend on evals. It's kind of the wrong framing, I would say. It's kind of like, if you're writing software, you're going to write tests, hopefully. And so it's like that. It's just, for at the moment, carved out as a thing that I'm teaching because it needs to be taught. But hopefully it just gets swallowed back in and kind of disappears into the background as sort of common sense after a while. But at this point in time, it needs this kind of special treatment, which is why I'm focusing on it.
Yeah, exactly. Because as you said earlier, like so many newcomers are coming into this that don't come from that foundational background of like, I'm sure all three of us have seen people build a regression model and not validate it and ship it to prod and then see it fall apart and like predictions are really far off from ground truth. They were looking at what went wrong and then like we come in and like we need to like validate this with holdout data first before we ship anything, and then lights turn on and all of a sudden quality gets better. But what you just talked about with evals, I was having very intense flashbacks of the last 20 months of my life prior to transitioning from engineering into the field again. Because the team that I was working on at the ML Flow team, we went through that exact evolution of from a platform side of providing eval solutions for people. And the first generation was exactly what you said of like, yeah, these are like the standard evals that a software engineer thinks of as this is how to get quality assessments, and they're all generic. And even while building these APIs, we're like, these like, are these even useful? Like, are people going to like get any value out of this? And I'm sitting there like working on this stuff. I'm like, no, like the way that you do this, and we kind of dog fooded stuff and learned it organically. Like we can just call a different LLM than the one that is actually generating this and have it like construct a prompt of like, this is what you should be looking at in this response. Tell me, is it good or not? Does it meet these criteria? Which that over time, like 6 months ago, we finished the make judge API in MLflow, which is basically you just type instruction set and then you can pair that up with DSPy and it can like auto optimize your prompt based on your criteria score that you set. But when you look at the bill at the end, I remember testing it over a weekend one time. I'm like, oh, I just ran out of OpenAI tokens. That just refreshed $50 onto my account because we were doing like hardcore testing of that.
A
So yeah,
DSPI will make tons of LLM calls in its
yeah,
optimization path.
yeah. I ran a test on like I think I created 5 judges and told it to just optimize all of them in like an async process. And then I
Yeah.
looked at the total count. So I'm like, okay, 6.7 million tokens just got burned in the last hour. That's a big bill. Did I just get
Yeah.
charged for that? Check my credit card statement. Like, yeah, like $175. Great. So then we put restrictions on like how many loops can it do for optimization. But yeah, like, I think it's going to be an uphill battle. I don't know how you feel about it when you talk to people about this, about that sort of getting that into the zeitgeist of people that are wanting to move fast and build these things because they're going to hit those walls of quality. And then they're like, well, the eval said they're all good. Or like the ones that come from this provider, everything's green. But my users are saying that this sucks. How do I even get started? I'm interested in
Yeah.
how you have that conversation with somebody who's in that state to get them to like, let's think about this differently.
Yeah. The magic moment is always getting people to look at the data. And when they first say look at the data, they're like, what the hell are you talking about? Like you want me to look at the data like a Neanderthal and like a monkey, you know? Like you want me to look at a logs? Like why can't a computer just do that for me? You live in AI, why do you want me to actually like open the data and look at it one at a time or like individual? That seems like intractable and it seems like you're telling me advice that sounds wrong. And I'm always like, okay, just trust me. Just humor me for like 30 minutes. Let's do it together. Let's look at some of your data. And what we do is we take trace logs. So trace logs are just, logs are structured from AI applications because you have a sequence of events or sequence of messages. And so the first thing I do is I usually code up like a very customized trace viewer for that person's application. And the reason I do that is everyone's data is different. And the last thing I want people to do is be reading raw JSON logs or unformatted text or things that they have to like then imagine how it's going to look to the user. So what I do is I make sure that like I have like a really great trace viewer annotation tool. Usually it takes me like 15 minutes nowadays because coding tools are just so good, especially at rendering data in a web application. And I'll dial it into the domains, and I'll do little things like the system prompt is always the same. I'll make sure I hide the system prompt by default. If the application is generating an email, I'll make sure it's rendered to look like an email. If it has images, I make sure like the annotation tool has images, like it renders the images in line. If it has widgets of any kind that it exposes to users, I'll render the widgets. I'll make it look as close as it does to the user, and I'll make it look like as interpretable as possible. That's key. So make it look like real. Sometimes you don't need to do this. Some applications are so simple you just use a spreadsheet. So I'm not saying you have to do this like every time. If you can get away with a spreadsheet, do that. Use the simplest thing that works. The idea is like you want to take away all the pain of looking at data. And then like every single time we look at data, it's 100% of the time. I've done this at least 300 times now over the last year and a half, is we just learn a tremendous amount. We're like, wow, our application is failing in XYZ ways. And I didn't even know that. Like, we're missing this, like, we're telling the user that something is happening, like an email is being sent, but actually the wrong tool is being called. And the AI is telling the user, we sent it, and the user is happy. So, yeah, great, thank you. So, if you try to put an LLM judge on that out of the shelf, it'd be like, yeah, this is great. Everyone's happy, everything worked correctly. But you don't know if things are working correctly. Like, only you will know. You have the context, right? And you have the context of knowing from a product perspective, like little things like, okay, like if it's a sales assistant, for example, and the LLM honestly replies like, hey, I can't help you. I'm sorry. But as a product person, you're like, actually there's something we could offer that customer. We could have handled that objection, or we could have, proposed an alternative that was kind of suitable to that. You wouldn't be able, like the LLM wouldn't know that. It wouldn't know that. And there's a process that happens of like when you look at this data, it elicits the requirements from you. Like you don't know what you want. We're not great at just one-shotting our requirements. We actually have to like look at data to be able to force us as human beings to tease out what is good and bad. And so like this reaction of like, actually like I thought I wanted to work this way, but actually wanted to do something else. But now that I see this is what is happening to the user, this is very confusing. Or like, why is the user having to ask like 5 times to be transferred to a human? It keeps asking for confirmations or something like that. I'm just like, I'm just thinking of real examples that I've seen where an LLM judge will totally pass it. They'd be like, the right thing happened. It looks great. But a human would be like, no, no, we need to stop right now.
Yeah, that's a really interesting point. Look at the data is a potentially obvious thing to say, but the response from many people is also potentially obvious in that JSON isn't fun to read. So you argue that creating a trace viewer that makes it that the insights almost like jump out of the page, that's really effective. And taking a step back into ML, it's the exact same thing with charts. If you think about residuals or the errors between predictions and observed, those are hard to understand, especially if they're in high dimensional space relative to your features. So that's what charts are for. That's what summary statistics are for. And likewise with AI, maybe making a trace that's more viewable, it's very similar. So I'm curious, are there summary statistics or charts that you use for Gen AI consistently?
Okay, so when we start with looking at the data, we can start with something very simple like random sampling. And that's a great way to start when you're first beginning because you're just trying to learn. But as you build your intuition over time, you build hypotheses, then you can start sampling in a more sophisticated way. So you can do things like you can calculate statistics about the traces, like number of turns, duration, number of tokens, and you can start looking for outliers. And you can do semantic search of your traces. You can do all kinds of things. You can bring your entire data literacy to bear on how you mine the data and look for interesting traces to look at. You don't have to always be looking randomly, and you shouldn't be looking randomly, right? It's like it's exactly taking the data scientist mindset. When you first start out, you start like very exploration, and over time you start to build lots of strong intuitions, and you start to build a smell of like where you can always smell where the problem is when someone tells you what the problem is. You're like, I'm going to go look XYZ places. And the only reason you have the smell is because you've looked at a lot of data. Like, kind of like, like you should poke around here and there. And so, yeah, absolutely. You can build charts, graphs, things like that. The most important thing is like you want to be hands on with the data, and you want to sort of, yeah, you want to look at it, because there's just no way that an LLM can, like, it's not even if an LLM could read your mind, it would have to do more than that. LLM would have to completely simulate your mind perfectly to be able to know if something is wrong, because you don't even know what's wrong until you
Yeah,
look at it.
and the world, the business context that you're applying it to.
Yeah.
Yeah. Yeah. It's like only your reaction to it will help you see, like, this is not great. It could be better. And then, so, okay, like when you look at that and you see all of these, so that's the most powerful part of the whole stack, right? Is like looking at the data. Everything else, evals, is downstream of this. Once you are pilled of like, hey, I really think looking at data is super valuable, then everything else becomes easy. Building the evals becomes a lot easier. Improving your application becomes a lot easier. But even if you didn't build evals, you just looked at data a lot, you would get really far. Like you would be way ahead of a lot of people. Um, even if you just, yeah, even if you didn't do anything else, because a lot of, and this is what people skip, this like look at data. And it sounds very trivial. Look at data. It's almost like I'm gonna hold open your eyelids and have you stare at data. That's not really what it is. It's like, okay, there's a skill, There's a skill, like some of the things I mentioned, like, okay, you know, take away all the friction, make it enjoyable to look at the data. And then, there's all kinds of ways of different sampling of the data, um, and searching the data. And you can cluster, things like that. You can do all kinds of things. But at the end of the day, it's important for you to like know what's going on. And then of course, like when you do evals, then that even, those failures that your evals emit, then you will be looking at those. And so it all is like a feedback loop that helps you improve, and it becomes easier the more you build it.
Yeah.
Do you think
So
the psychological block for the people that are getting into this field is because of kind of system training in the output results of unit tests? So when we like file, like working on, just from pure software engineer perspective, you're working on a repo, you read all your unit tests, you're no longer looking at like debug logs of the output of stuff. You don't really care. You're just like, I am confident in the invariant status of this unit test being an effective adjudicator of my source code. So all I'm looking at is a green round checkbox. Like 1,300 tests just passed. Sweet. File PR, get approval, merge, on to the next thing. Whereas data science work is more slow down, check to make sure that like things are working the way that you expect, because this field that we're trying to cross is filled with landmines. And if we're not even looking for them, we will step on one. Do you think
Yeah,
that that's
I
like the
think,
psychological
yeah,
block?
I think it's a psychological block. I would say it's almost the antithesis of, or the enemy of, the thinking you need to do evals correctly, because you need a very experimental mindset. There's almost no determinism. And one way, for example, where it creeps up a lot is the last thing you want to see is 100% pass rate in your evals. A software engineer would be like, "What do you mean?" They would like, "I want 100%. I want to see everything green. If I see one red check mark, I need to stop and like fix it." No, not with evals. Last thing you want is 100% pass rate on evals. That means your evals are not helping you. And the way I like to explain it is, if you gave a test to a classroom full of students and all of them passed with like 100%, no mistakes, maybe that test is not good. What's the point of the test? To make everyone feel good, or to figure out like where the strengths and weaknesses of your students are. That's what your test is for. And so, in the same way, that's what evals are for. You should always have, you want to have evals that you're failing on. You need to have evals you're failing on. And so people don't. They're like, that's weird. Like, you want me to put tests that I know I'm going to fail on, that like I don't even know how to like fix? Yes, that's great. You should absolutely put tests in your eval set that you have no idea how to fix, that you even worry that you may never fix. Like you don't even know if it's feasible. That's great. That's a great eval actually, because you can make progress against that. We can try to hill climb towards that. That's exactly, you want that signal. You want that feedback signal.
Yeah, one of the classic traditional ML use cases that I like to bring up is fraud detection, where 99.9% accuracy is actually bad because the class is so typically biased to not fraud that if you just predict that there's not fraud, you're going to have really high accuracy. But if you actually go and look at the data and look at the incorrect classifications when there actually was fraud, you'll actually learn a lot more about this error space and sort of why the predictions are the way that they are. So 100% when you give an eval that you know is not initially passing, you can first of all work towards making it pass. But second, that's an actually representative case of what the real world is like. So it's super, super essential. But I'm curious. So we've sort of laid the groundwork. We know what evals are. Let's talk about the future. And you at Parlance Labs are building products around this. You're teaching courses about this, and you have a lot of experience in this space. Ben has a lot of experience in the OSS side with ML Flow. It's actually been really fun to watch the trajectory of how they've approached evals. And I've worked on the forward deployed side and know a tiny bit. So taking a step back, do you guys think that evals are the link between the business problem and the code itself, and thereby will never be able to be outsourced fully to an agent?
Yeah, so I think a lot of the glue code can be done by an agent. So there's a lot of tedious parts of evals that you can outsource to an agent, but the what can't be outsourced is your taste. Like that's the only differentiation between you and someone else. It's like your taste and your opinion of what is good and bad. And that can't be outsourced by definition because, well, it's your taste. Unless we figure out a way to lift your neurons out of your head or do some kind of telepathy into an LLM or do something like this. Now that's like kind of a little bit of the spicy answer. Another kind of middle ground is like if you work really hard on this process of evals, it gets easier, right? Because you are writing down and you are externalizing constantly like your taste. So it does accumulate like all of those prompts and all of those harnesses and systems, they start to embody your taste. And then it's not, you kind of can then move faster and faster and faster. And the evals get faster. But like, okay, what do I mean by like automating parts of eval? So like, okay, instrumenting your system. Instrumenting your system used to be super painful. You got to put all this code everywhere. Let's say you using open telemetry, even you got to like put that code in the right place and like get the trace all the way through. And you might, even if you have a distributed system, you got to worry about all this. You had to, depending on what framework you're using, you have to set up your code to like run experiments to track the metrics. um, you had to build, you had to do all the scaffolding before, build your LLM judge, you got to wire everything up and whatever. A lot of that tedious stuff is just now you can prompt it, honestly. Like it's AI is really good at getting that stuff into your code base, and a lot of that toil is gone. And also another example I gave, like you can reduce a lot of the pain, like this trace annotation viewer thing. That wouldn't be feasible before AI coding. Like there's no way in hell, like for every single person, I'll make their own bespoke trace viewer customized to them. That would just be way too expensive. Like no. But now, like you have to, because it's like so cheap. Everything melts away, I feel, except for you like communicating your taste, looking at some data. Now even the looking at data part, AI can help you sample that data potentially, and like you know help you explore that data in a very efficient way, and use all of some more of these techniques that I talked about, like clustering, semantic search, running statistics over the data, doing all these things. So I think like as long as you know the process in your mind of how you want to do it or what the right way to do it is, then I think AI can help you drive it. But you need to figure out, okay, how are you going to get your taste in there? That's my opinion.
Yeah,
I'm
I
curious what
actually
yours has
couldn't.
been.
I couldn't agree more. I've actually in the project that Michael and I are working on right now. I'm not like invested in evals right now because I'm just the code monkey for backend stuff. But there are other people that like Michael's working on agent development and stuff and evals. But my actual dev workflow is heavily involved in like Gen AI usage. So Claude Code as like hardcore, just type for me, basically, starting planning mode and stuff. But what I actually do is I extract the plan that it comes up with. I'll write a whole page of text of like, here's what I'm thinking of this feature that we need, or we need to harden the back end in this way. Start planning mode and figure out what we need to design. And I have it write that out to a markdown file. I open that up. I then edit it, and I might change like 20% or more, or I might actually just add in entire paragraphs to like refine that. And I tell it, hey, I just made changes to this, evaluate what I just did and like format it in your execution plan. I then take that and I put that into Codex or ChatGPT, and I said, and I give it the preamble of like, here's what I want to do. And this is what our buddy Claude just came up with. Now put on your systems engineer hat and like, let's jam together for a minute. And I use the GPT systems as kind of a rubber duck for me of like, am I missing something? Like, have I not thought through this well enough? And sometimes it'll say like, hey, you're overthinking this part. Like, here's a simpler way. And I'm like, you know what? You're right. Like, yeah, okay, let's do that. And then it'll be like, actually, you bring up a really good point here, and we can make this a little bit harder to mess up in the future or make it more testable. So let's do this instead. And I'll then give that back to Claude and see what its take is. It'll revise the plan. Then I do another loop of that where I edit it, tell it to my buddy GPT, and then we finally get something that's like, here's the plan that all three of us agree on. And then I say, okay, Claude, at each transaction point, you need to write tests, run them, make sure they pass before moving on to the next stage, and put a pause point in so we can review the code. So it takes longer than the whole vibe code, like, yeah, let's go, baby, go, and we'll ship the PR. But that whole like the human in the loop aspect of that, of like, I'm more of the systems architect here, and I don't want to write 15,000 lines of code in an afternoon. I can't do that. I'm going to make a lot of mistakes and my fingers are going to hurt. Each of these systems can't do that, like the entire holistic role. They're just not capable of it. They're not optimized for that. Their guardrails aren't put on, or their objective functions aren't designed for that. But you can interface with these systems in such a way, including with stuff like evals and any task that you're going to do, where you can get this symbiotic relationship between differing systems where you can accelerate and go very quickly if you have the right sort of control balance, and also doing stuff like instructing them to do exactly what you were talking about earlier, which is look at the output results. Like, don't just do the vibe coding demo mode. Like, turn on debug logging and then run it yourself in a shell and like look at the actual outputs of every single thing that's coming. And if you see something weird, stop, let's talk about it, let's fix it. And you get like higher quality results, in my opinion. And you can ship a feature that I would have taken me 2 weeks to do, I can do in a day now. I think the same thing is entirely possible for evals too, but it's not like you have to do exactly what you said. Like, just look at the data, even if it's just a notepad that you open up, just write down your thoughts and then give that to another, like to a Gen AI system. Be like, here's the data results and here's my thoughts. Do you see anything that I'm missing? And then see what it comes out with. It'll probably be like, you caught some really good things. Also, here's 4 other weird things that you might want to look into. And then you can refine that and be like, all right, man, let's build an eval judge that can detect this, run it, make sure it detects it, and then iterate again. So I think
Yeah, I really like that.
using these systems is, if you use it right with like what these things are good for, you can move really quickly and not get into that paralysis position of, I need to take 2 days and manually look at every trace. Like, that's mind-numbing work if you're doing it for like 100,000 traces. But you better do
For
like the
sure.
first 100 yourself, like 100%.
Yeah.
What's
And by doing
what's
the
the
first 100
frontier?
per
Or go ahead.
yourself, like you said, like you're grounding the LLM. You're like, hey, I found this, and the LLM can like kind of now be at a much better place to like jam with you, like you said. If you just went straight cold into it, like, hey, just look at my trace and tell me what's wrong, it's not going to go well.
No, no, it'll find stuff that's like so irrelevant. But if you have that like mental model, you can actually be the control feedback loop for that agent to be like, dude, you're looking at the wrong thing. Like, here's the actual business problem. And once you like do that corrective loop, it's like, I got you, man. Let's look at this through that lens. And then now you can scale your capability in your mind within that context for that problem. I don't know how many people use Gen AI like this, but it seems to work for me.
Question to
No, I
both
feel
of
like
you.
yeah, go ahead. Sorry.
What's the frontier? If we take a step back, think about ML. Let's say we're just doing classification. You have an F beta score, which is it's an F1 if you have precision and recall weighted the same, and you can weight differently based on your use case. That's a pretty well scoped initiative because there's a lot of history behind it, and also it's a pretty simple dimension. Once we get into text, it's highly dimensional and way more complex. And so my question to you guys is, and this is hinting at what part of jobs are safe. To me, when you inject context to an LLM, a great way to do that is with evals. So you say, this is what success looks like for this use case. It's not an F1, it's an F50 or whatever it might be. And you know, as the business user, that you want to weight different errors differently and focus on different areas of the residuals. Will LLMs, and is the capability of Gen AI, will they be able to actually do that? Or is that the fundamentally human part of Gen AI development?
I mean, I think what you're getting at is something that I think even data scientists and ML engineers, I could speak from my own perspective of doing this before. If it's self-contained within my own team or myself of being the quality adjudicator of something that's actually, what is the end use case of this? Is it another system? Then it can be like easier to reason about objective scores of like, this is either true or it's not, or this is predicting accurately or not. The moment you pass something into the hands of a human, you introduce subjectivity, quality adjudication. Different people will rate that exact same experience in completely different ways. So I think the only way that an agentic system would be able to give you what everybody wants, what the mean quality rating would be, is if it was able to interact with individual users or to collect the feedback from them. So perhaps in your app that's facing your users, give them the ability to like dunk on it. Like, this sucks because of XYZ. And now that becomes justification and rationale in your evals. Without that, even the world's greatest machine learning engineer is building an amazing system. You're still just like, I think it's good, but my users don't. Like, what's the disconnect here?
Yeah, that's one of the Databricks products that I won't say too much about, but basically it's an opinionated way to go through a problem space and collect subject matter expert feedback, convert that into LLM parsable data representation, then convert that into judges. So that's a way that at least one part of the Databricks product is angling. But I'm curious, Hummel, what's your take on Parlance Labs? Like, is this the where are you guys shooting for the next few years? Because models are going to get better, probably. I mean, I think that's a fair assumption. So what parts are you still delegating to humans versus hoping that AI will overtake and thereby just sort of patching that until AI is ready?
Okay. Yeah, let me address like one of the other kind of things you raised before answering this is like, hey, how do you deal with all of these little nuanced decisions of like all these different kinds of errors and how do you weight them? So, one of the things, and taking from machine learning, again, like what we teach people is, hey, you want to scope your evals very carefully. You don't want to be like one eval that is trying to assess like 100 things. You want to have, very specific evals trying to capture a specific error. And then you don't want to you want to stay away from Likert scales, like 1 through 5 ratings, because 1 through 5 ratings, like no one can align those. It's extremely, you have to write a rubric. No one can agree on what the hell that is. And then at the end of the day, you got to ship the product. So just make a damn decision. Like, is it good enough or not? And so we say, okay, like make everything a binary classifier. Like in your LLM a judge needs to be a binary classifier. And so, yeah, we do that to kind of make sure that people can that this stays tractable for people, like that, like kind of these decisions. Of course, you might want to aggregate all of these different errors in a specific way, and that's kind of a judgment call. But as far as like the future of, okay, where are evals going, it's increasingly clear that, so in the last, let's say before, like let's say the last 3 months before coding agents became really good, one central concern of evals was infrastructure and software. Like, oh, where's my trace logging system? I got to log it to XYZ system. What's that API? I got to, maybe I want to, log my experiments into this, vendor. And I want to track my experiments there and do all kinds of stuff. And that was a core skill. That was a core piece of like some subset of skills that you really sort of needed to get your hands around to do evals effectively, is to kind of drive all the infrastructure. I don't think you're going to need to drive the infrastructure, because you can go through your coding agent, because now your coding agent is the thing that's going to be interacting with the infrastructure. That's increasingly clear. The infrastructure is going to expose APIs, MCPs, skills, whatever, I don't know, whatever it's going to be, and like you are going to then be interacting through it with your coding agent. And so I think everything, the tooling is going to melt away, and you're going to be left with process. And I think tools have not completely caught up yet to this. They're still designed a little bit more for humans, let's say, than agents. But it's very clear that they will become increasingly designed for agents to like read and write from and interact with, and make sure that's like really good, really friendly. So yeah, I mean, people in my evals class also ask me, can we just have skills for everything? Like, Hamel, can you give me a skill for how to do error analysis, how to do like the different parts of error analysis, how do you write an LLM judge, how do you whatever. I'm a little bit hesitant to give people a prompt they can copy and paste. The prompt you copy and paste is always a danger, in the sense, I tell people, you may want to think about what you know plus your domain and write your own prompt, because my prompt is going to be generic. um, Maybe there's some things you can codify. But I think the infrastructure melting away is the biggest kind of unlock in the future of, like, because that was really tedious, to be honest.
That makes sense. And so infrastructure means logging traces and creating interfaces that are very AI readable. Is that what you mean by infrastructure? Is it
Yeah.
something
Okay. So
else?
like logging traces, creating and logging experiments, interfaces to read traces, prompt playgrounds, all the concerns, all the trappings of your modern day evals vendor, let's say. A lot of them melt into the background of, like, you still might use them. I'm not saying it's like they're worthless or anything close to that. It's just that you won't need to be an expert in that,
Right.
so that software. Like, you will just need to express what you want to do, and then you can do it.
Yeah, like in almost like infrastructure standards of cohesion between services. Like that's the biggest thing that I mean, like that's the stuff that we were working on, or I used to work on, is like how do you build that back end to make that possible? And when you look at the complexity that's involved in building framework code like that, you're just like, in order for a user to be able to plug this into their workflow, they have to come and look at my code and reverse engineer it and understand what the access points are in the back end. How many people are going to want to sign up for that? It's just so ludicrously complex of like, well, why did he decide to make this protobuf contract instead of like making the schema this way? I actually need to change this. And they realize I've just signed up for a month of frustration and like writing you effectively extending a product in such a way that, congratulations, you now own your own fork of this in order to do this little thing. Whereas in the future, it's like, no, here's a contract that like Claude can talk to or Codex can talk to, and it like fundamentally understands how to debug and interface and just make all of this work. So a human can be like, I think something went wrong like 4 hours ago with this user using my app. What do you think we should do? And in the background, it's like, I know exactly where to go to get the data for this. I can go and pull the source code. I can see like where the bug might be, and then provide a, hey, here's a diagnosis of like what went wrong. And I think I have a pretty good plan of like how to fix it. Do you want me to proceed? And you look at it and you're like, yeah, sounds legit. Go do it, buddy. 5 minutes later, hey, I've got a PR ready. Do you want to file it? I think that's going to be the future. But exactly as you said, like it could, like systems like that could be like, I need to actually write an eval like instance of this to test this against like my fix that I'm about to apply. How is that going to change all of the previously passing good traces that were coming through? Like, what is the simulation here? Am I going to create a problem for the user, or am I going to fix the root cause here without regressing?
Yeah,
I
no, I mean,
100% agree.
I think you can already see that happening. Like even in my day-to-day work, I'm able to. So there's different popular vendors out there: Langsmith, Brain Trust, Phoenix, Arise. And if I want to migrate data from between one to the other, they each have like different target schemas. If you're try to like export the data, it doesn't matter anymore. I can just tell Claude, be like, hey, I need to take this data, put it in that vendor, has a different target schema. I don't even care what it is able to figure it out. And that would not be feasible before. It would have been like very painful, right? To parse that data, be like, what is the schema exactly? Oh, there's an exception here. Okay, I need to. You would just take like days. Things like that. It's like it doesn't matter anymore. Like the idiosyncrasies sometimes of the software you're using kind of doesn't matter. So yeah, I think it melts away. And I think evals becomes more important when you're building an AI product. People are kind of catching on to this harness engineering idea. It's not necessarily like new per se, but it's like, the OpenAI blog post of like, people. So so there's like a bunch of different components of the OpenAI harness engineering blog post. One is, okay, of course they have very detailed documentation and instructions on like all the various different concerns of their application, of like, including testing. But another thing they have is instrumentation. So they've created an environment where in the testing workflow, they have in their sandbox, they also create a way to have the instrumentation spin up, and then the agent is reading from the instrumentation. And I think, you know with evals, if you have really good instrumentation and you have like evals that can run, and the AI can then introspect the evals, and when you make a change, then you're going to start to build a very powerful workflow for yourself. Like that's when you can really like, not you're not just talking about software now you're talking about functionality. Now you're talking about quality of results and user experience and all that other stuff that you want to make sure it doesn't regress. And so that will just like, it'll just become leverage.
Yeah, it's something that a colleague of mine on the MLflow project actually created. I think it was like 5 months ago. Was basically agent as a judge that has the ability to, you give it the prompt instructions of like, here's this application that we're going to be judging, and like here's its functionality, and look at the actual user input as well as the system prompt that went into this. But it exposes not just the inputs and outputs of a trace, it exposes all the span data. So it can infer of like, based on the question that was asked here and the tools that are available to this agent that you deployed, it should have called these 3 tools. It did not. Or it called them, it ate an exception and it just kept on going. That level of eval, it's very sophisticated, and you can do it right now in MLflow, but holy crap, is it expensive to run that on like a large volume of data, and it takes forever because it's just running in agent mode. So it's making its tool calls to MLflow APIs to acquire the data that it needs for context. And you look at the trace of that eval run, and you're just like, how many spans are in this? 873? Like, what the heck? How many tokens did I burn through? And you're like, Yep, that was 257,000 tokens for one user input, but you get root cause on every single one. When you look at it as like for something that's main product that you're pushing out there and you have thousands of users, that cost benefit analysis, all of a sudden, it's like this saved me potentially just rabbit holes of going through and testing a bunch of stuff. And it just found it in an hour and came up with a report that's like, yeah, this is actually like, thanks, buddy. We can go and fix this now.
Yeah, and we
Okay,
just
so
released.
it doesn't sound that expensive in that case. Because it actually sounds like it saved you money.
Definitely. But a lot of people see that and they're like, yeah, this is complex and it takes a long time to run. And they think like, okay, that's more of a diagnostic tool in my opinion. Like I'm trying to debug something that is just too complex for me to like really dive in. I've got a delivery at the end of the week. I want to have a weekend. So using something like that as a debugging tool is great. But we've actually heard from users that we are interviewing. They're like, yeah, I turned this on in prod and it's really slow and expensive. Like, dude, don't turn that on in prod. Like write a very simple, like figure out what you found in that debugging. Now go write an eval for that exact use case if it's so critical, and that'll run in like less than a second. It'll just it's just checking for it, or write a Python function that just deterministically checks to make sure with this input did I get these tools called, and that's just parse the JSON, look for this key, look for the status result, pass or fail. And once that kind of clicks in them, they're like, yeah, that's way cheaper. Like, yeah, just do that.
Yeah, I love it.
Yeah, well said. So we're coming up on time. I will quickly summarize and then kick it over for any next steps. But really fascinating conversation. We actually stayed on topic, which was odd to see. We spoke a lot about evals. Evals should not be generic. Instead, you should look at your data and let the evals emerge from said data. What that means specifically is focusing on traces. You can start off with a random sample and manually look at them. And it's really helpful to have a UI viewer that makes the trace more readable. So not just a big JSON blob. Some other evals tips, don't do Likert, instead make every eval binary, and also make them very specific. So check a specific criteria, no more, no less. Looking to the future, eval tooling will likely cater to AI users, and we would probably have agents sort of orchestrating and moving around this eval infrastructure space. Looking forward, we would expect evals and the infrastructure associated to sort of just work, leaving the human aspect to be a very small slice of the infrastructure management. And as Ben alluded to with the adversarial approach of Claude versus GPT, adversarial agents for code gen are pretty cool. So Hamel, if people want to learn more about you or Parlance, where should they go?
Yeah. So since we talked about evals today, I would highly recommend if you want to learn more about evals, I teach a popular course on the subject. We've taught over 3,000 people on the topic from over 500 companies. It's one of the most popular courses on evals in the world. You can find it at evals.info. That's the URL, evals.info. Check it out, as that gives you 25% discount at that URL. But yeah, that's what I would direct people to. And then from there you can find all kinds of other information about like how to get in touch with me. My blog is on there. I have some eval flashcards on there. I have some other resources. So yeah, please check it out and get in touch.
Sounds good. Thank you. Well, until next time, it's been Michael Burke and my co host,
Wilson,
and have a good day, everyone.
we'll catch you next time.
Thank you.